Are you being intentionally dense?
Sparse versus dense. Think of it like roommates. Sparse roommate keeps only what is necessary. Rest, it's empty space. Well, in machine learning paradigm, sparse is equal to efficient but harder to store, whereas dense is heavy but powerful.
It doesn't matter what you think.
Let's understand this with the help of a practical example of sparse. So text data, back of words, right? TF-IDF features when representing documents as word count vectors or TF-IDF vectors. So for those of you who do not know what TF-IDF is, comment TF-IDF and I'll make another video on TF-IDF. Each position corresponds to a word in the vocabulary, which can be tens or hundreds or thousands. Since any individual document contains only a small subset of all possible words, most entries in the vector are zero. Hence, the vector is sparse. Pretty obvious, right? Corpus documents. So, well, we have vocabulary in AI, data, model training. The document one, AI, data, AI model training, and data model. So, if you do the calculation, well, in case of IDF calculation, you're just taking out the logs, and then based on after this calculation, you got finally the sparse vectors. Well, not confusing you, but imagine giving a giant checklist to every document, but only checking a few boxes, right? Most spots are empty, so the list is mostly zeros. That is exactly what sparse vector actually is. The same way we can understand for dense vectors, where word embeddings such as your word to vec, glove, BERT embeddings are there. Then these, encode semantic meanings in low and dimensional dense space. So there are two things. One is syntactic and another is semantic. Okay. So again, mention semantic versus syntactic, and I'll make a separate video on syntactic or semantic if that needs to be understood. Word embedding vector, example 5D, such as king, queen, man, woman, apple, orange. Okay, so these are the embeddings that you can see. Now, why dense? Every word vector consists of all non-zero floating point values, which are no zeros or sparsity. The 5D vector compactly encodes semantic properties, for example, gender, royalty, fruit, category. Notice how king, queen, man, and women vectors are close in vector space, small Euclidean distance, cosine distance. Well, in one of the videos, we covered Euclidean or cosine distance, so you can refer that for this particular understanding. King minus man plus woman. This is a classic analogy which is used in the field of data science. So king minus man plus woman equals queen, which is also true. This kind of analogy is possible due to dense continuous vectors only. Well, to simplify this, think of each word as having its own unique recipe. Lots of ingredients all mixed in, so every number in its list tells you something special about its meaning. So now, are you a sparse roommate or the dense one? You know whom to tag. Also, if you want to have an understanding of tokens, one hot encodings, and how stuff works, follow NextByHardik.